All right, we are back with section 6.5. So, present and future value. So this is going to be a really quick one. We're not going to do too much with this, just a quick example here. But when we're talking about the present and future values, so the present value, which is labeled P, of a deposit, is the amount that you would need to deposit today in order to obtain a specific future value. B, after a certain amount of time. Okay, so present value is how much I need to put in today to my account in order to obtain a future value after a certain number of years have passed. Okay, so if S of t is an income stream in dollars per year, for example, R is the continuous interest rate, and the deposit is made t years in the future, and M is the number of years until we determine our future value, then we're going to have the following formulas. The present value is going to be determined by the integral from 0 to m, okay, so this is counting the number of years, of S of t times e to the negative rt dt. Okay, now I want you to think about this for a second, why that might give us the present value. Okay, so we're going from 0 to m, so we're looking at the entire lifetime of the investment between now and the future value, with this much money coming in, okay, an income stream in dollars per year, and then e to the negative rt. Think about what that's going to do, right, with our interest rate and t, because t is only going to increase, right, as time passes. So why is this negative? Well, negative is going to shrink the value, right? It's going to make it fractional, which means that we're taking the full amount we would have after m years, and then we're backtracking to see how much we would need to put in today in order to get that amount out. Okay, and then the future value, which we're talking m years in the future, future value would just be present value times e to the rm. Present value times e to the rm. Okay, so and now this one represents exponential growth. So there's where we're going to start seeing the money growing, right? If we put this amount in, and then we let it sit there at this interest rate for this many years, then that's going to give us, the information for our future value. Okay, so let's take a look at an example. So find the present and future values of a constant income stream of $1,000 per year over a period of 20 years, assuming an interest rate of 6% compounded continuously. So let's identify the pieces that we know already. So I know the income stream is $1,000 per year. So S of t equals 1,000. The interest rate compounded continuously is 0.06, and the number of years in the future we're looking is 20 years. Right? It's a 20-year period. Right? 20-year period, interest rate of 6%. So, to get our present value, so P, this is going to be the integral from 0 to 20 of 1,000 e to the negative 0.6t dt. Take the integral, so take the antiderivative of this, so that's going to be 1,000 e to the negative 0.6t over negative that should be 0.06. 0.06 on both of those. E to the negative 0.06 over negative 0.06. Okay, by undoing that chain rule there. So we've got that up there, and then this is getting evaluated from 0 to 20. So we get 1,000 e to the negative 1.2 over negative 0.06 minus 1,000 e to the 0 over negative 0.06. And exact answers, that's pretty much as far as we could go, but we can use technology and see that the present value is approximately $11,647. Okay, so that gives us how much money we would need to put in now. And the future value tells us if we do that, if we put in that amount now into this specified account using these numbers, so with a $1,000 per year income stream over 20 years, 6% compounded continuously, if we put in this amount, we would get out at the end of this 20-year period present value times e to the 0.06 times 20. That's just telling us how much interest it's making. And that is approximately $38,669. Okay. So we put in over $11,000 now with all these conditions being met. All these conditions up here. And after the end of the 20-year period, we will end up with almost $40,000 in the account. Okay, so that's pretty much it for present and future value. We're not going to dive really any deeper into those. And we're almost done with the chapter. So when we come back next time, we're going to talk about section 6.6. We're going to look at one more technique of integration that we see comes up pretty frequently that will help us deal with some more differentiation formulas. So that's all I have for you today, and I will talk with you all very soon to finish off this chapter.